So section 4.4 says using congruent triangles, and then it says CPCTC, and that's an acronym to stand for a phrase that we're going to learn below. But you want to memorize the CPCTC. You'll hear me say it a million times, and you'll also hear me say what it means a million times, both today and tomorrow. All right, so the warm-up at the top, I do want to look at this today. Sometimes we skip these, but we're given a congruent statement. Triangle TIC is congruent to triangle LOK. So they want us to list, if we know that the triangles are congruent, then that means all of their corresponding parts are congruent. So all of the angle pairs are going to be congruent, and all of the side pairs are going to be congruent. So who could give me one pair of congruent corresponding angles from the congruent statement? Remember, corresponding means that they're in the same location in the congruent statement. Marquise?
Angle T is congruent to angle L.
Good. The first letter. And if you wanted to, you could draw a picture to represent these two triangles. But, Halen?
Angle I is congruent to angle J.
Good. And lastly? Peace?
Angle C is congruent to angle J.
Okay. So once you know the triangle is congruent, you know that you'll have three pairs of congruent corresponding angles. You'll also have three pairs of congruent corresponding sides. So for example, segment TI is going to be congruent to segment, that's the first two letters, and the first two letters would be LO. Who could give me another pair of congruent corresponding sides? Helen?
Segment IC is congruent to OK.
IC to OK. Good. And then there's one more. Marquise?
Segment TC is congruent to segment OK.
Good. Alright, so before break, we just found like side or angle side angle, and our last statement in the proof was that the triangles are congruent by that reason. What we're going to do today is we're going to use the fact that if we know the triangles are congruent, we can also conclude something else about the shapes. We can conclude that two of the angles are congruent, or two of the sides that we didn't have marked were congruent. And that's what CPCTC stands for. So, how many congruent corresponding parts do we need to prove triangles congruent? So what's the minimum number we would need to find to prove the triangles were congruent? 3. Okay, and that's like side, 3 pairs of sides. For angle, side, angle. 2 pairs of angles and a side, so that's 3 pairs. What are the 4 ways we know? Well, we know side, we know side, angle, angle, and angle, side. We're also going to learn another one in our packet, which is HL, but we haven't learned that yet. So, if the triangles are congruent, then technically all of the corresponding parts are congruent to all the parts. So like once you have, let's draw a picture here. Okay, let's suppose we had 2 triangles that were congruent by, let's say, side, angle, side. Okay, so in the proof, let's say we did all the work, we got down to our last step, the triangles are congruent by SAS. Once you state that the triangles are congruent, you technically could go and add markings on all of their parts. Like you could say, well, if they're congruent, then those have to be congruent. If they're congruent, then these have to be congruent. If they're congruent, then these have to be congruent. So once you have congruent triangles, all their parts are congruent to all the parts. And that's what this CPCTC is going to stand for. So if triangles are congruent, then all the other corresponding parts are also congruent. Now we're not going to have to mark everything, we're just going to be asked like one additional piece. So instead of having to write out this phrase, we use the acronym CPCTC, but it's important for you to know what it stands for. So it stands for corresponding, I think the C's already filled in for you, corresponding parts of congruent triangles are congruent. corresponding parts of congruent triangles are also congruent. So instead of having to write this out in your proof on the last line, it's a lot to squeeze in there, we use the abbreviation CPCTC. You'll notice that every other letter is a C, and it stands for corresponding parts of congruent triangles are congruent. Okay, so instead of having to write that out, we'll use the acronym CPCTC. All right, so our plan to prove CPCTC is just like we did before break. We're going to mark the picture and justify each step. We're going to prove that the triangles are congruent by either one of the ways that we had above, so either side, 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 angle, side, etc. And then we're going to add an additional step to the proof. And you'll know when you have to use CPCTC when you look at the proof statement. The proof statement is not going to say prove the triangles are congruent. It's going to say prove something is congruent to something. That's going to indicate that you're using CPCTC. So I suggest jotting that down right next to the proof statement to remind yourself, I'm not going to stop at side, angle, side. I'm going to have to keep going after that. All right, in this case, I'm given two pieces of information. I'm given that QS is parallel to RT and QR is parallel to TS. So I have two pairs of parallel, which is nice. Okay, just like we did before break. Most of you liked your shared side, right? You like to do that first, so let's mark that. Mark it, write it down. Segment SR is congruent to SR. Who remembers what reason we put for our shared side? Luke?
The reflexive property.
Very good. Reflexive property of congruence. All right, and then if we have two pairs of parallel lines, we probably have two sets of alternate interior angles. We will have to use 3 letters for these. So let me give one pair. Let's do this one first. Who thinks they could name those using 3 letters? I know sometimes we throw numbers in, but I also want us to practice 3 letters because a couple of you made mistakes with that on your last quiz. Who could name the congruent angles in this picture? Maddie? Hold on, say again.
STR.
STR?
Yeah.
No.
S.
STR would be this one over here. So let's switch it around and say TSR. S would have to be in the middle.
Yes,
Yes. And so we had TSR. You could also do RST, but S has to be the middle because that's the vertex. It's literally like you're tracing the angle whenever you name it. And that would be our if lines parallel AIA congruent or alternate interior angles theorem. And then since the other pair of segments are also parallel, that means that we would have another pair of alternate interior angles. Who thinks they could name those using 3 letters correctly? Marquise?
Angle QRS is congruent to
It's this black one. So
um,
it'd be Q.
QS is congruent to TRS.
Good. It'll be the same reason as above, which you could have put these on the same line. It's just hard for me to squeeze that all in. On your next quiz, again, if you want to throw in like 1 and 2, I'm fine with that. 1, 2, 3, and 4, and use numbers. But I wanted just to practice the 3 letters. Okay, and then you always want to kind of stop and see, like, do I have triangle congruence? Because as soon as you do, you want to stop and prove the triangles are congruent. So is this enough information to prove that the triangles are congruent? Yes, which shortcut theorem or postulate? No? Angle, side, angle. Very good. So we are going to have to state a triangle congruent statement. Now normally, it's given to you and you just copy it down. This time you're going to make it on your own. Remember, the way you name the first one doesn't matter, but you have to make sure the corresponding parts match up. So for example, maybe I want to do QRS. Looking at the markings, that's 0 marking, 1 marking, 2 marking. So I have to follow the pattern. 0, 1, 2, which would be TSR. Again, the order of this one is really important to make sure it matches up with how you named the first one. Okay? So if you were to name the first one differently, you'd have a different part. So now, once we know the triangles are congruent, that means that technically all the corresponding parts are congruent. If we wanted to, we could go mark them all. They just want us to tell you that QS is congruent to RT, which it would be. QS is congruent to RT because corresponding parts of congruent triangles are congruent. CPC2C. Corresponding parts of congruent triangles are congruent. So sometimes it's just adding an extra step. Sometimes it's adding 2 steps at the end. So we'll take a look at a couple harder ones on the back. And I will just warn you, I have an extra line on these proofs for some reason. I think we're only going to use 7 lines, but you could use 8 if you use like third angles theorem or something. All right, so this one we have JK is parallel to QP, so let's mark that in our picture. And it says JP bisects KQ. So remember, bisects means to cut into 2 congruent parts. And also remember, it's whatever comes after the word bisects. So KQ, segment KQ is being cut in half. So we would put markings on KM and MQ. JP is slicing through in half this segment. So since I marked that, I'm going to write it down. Segment KM is congruent to segment MQ. What do we think our reason would be for that? No? Perfect. Definition of a segment bisector. A couple of you lost a half point for just writing definition of a bisector. Remember, there's actually 3 types of bisectors. I'm going to make sure you specify this is a segment bisector. Okay. And then there's actually quite a few ways you can do this proof. So I'm just going to let you guys kind of tell me what you want to do next. So there's different types of angles that we could identify that are congruent. And you could get this proof correct by doing it, I think, 3 or 4 different ways. Maddie, what do you suggest? Vertical angles. Okay. Let's mark them. And let's write them down using 3 letters. So angle KMJ is congruent to angle QMP or PMQ. It doesn't matter as long as M's in the middle for an angle. For a triangle, it has to be specific, but an angle doesn't matter. And that would be the vertical angles theorem. Or you can also write out what the theorem says, which is VA are congruent. Vertical angles are congruent. Whichever you prefer. Okay. You actually could do this proof without doing vertical angles, but Maddie chose to do them, so we're going to do them. What else can we identify based on our given parallel segments? What else would we know based on the given parallels? Brett?
That angle A is congruent to angle Q.
Good. K is congruent to Q. You also could do J to P if you wanted to, because those are also going to be alternate interiors. But we only need 1 pair, actually, so I'm just going to write down this one. Angle K is congruent to angle Q. Those are alternate interior angles. So this would be our alternate interior angles theorem. Or if lines parallel, AIA congruent, whichever you prefer. Again, you always want to stop when you can. Like we see 3 things marked, so we should have triangle congruence by one of our shortcut theorems. So let's check and see. We have angle, side, angle, angle, side, angle. So we know that the triangles are congruent by ASA. So we will have to create a triangle congruent statement. And end, who thinks they could write a triangle congruent statement? Everyone's could be a little bit different depending on how you name the first one. Who thinks they could write one that matches up the corresponding parts? Halen?
KMJ is congruent to QMP.
Good. KMJ was 2 markings, 1 marking, no markings, and then 2 markings, 1 marking, no markings, so matching up the corresponding parts. Perfect. Now, let's look again at our proof statement. The proof statement, they want me to prove that M is the midpoint of JP. So this one's going to be a little bit, it's going to be 2 additional steps. So I want you to think, to prove M is the midpoint of JP, what do I need to know? How could I prove M is the midpoint of JP? What do I need to know? Joseph?
JM is congruent to MP.
Good. So to know that M is in the middle, I would have to know that JM is congruent to MP. So that's what I'm going to write down. JM is congruent to MP. Why? If I know the triangles are congruent, what tells me that those segments are congruent? Joseph? Perfect. Corresponding parts of congruent triangles are congruent. CP, CTC. Technically, you could go mark like everything is congruent to everything now, but we're just going to do what we need. And so now that we know those are congruent, that means M must be the midpoint, so our proof is done. And we didn't need step 8 this time. M is the midpoint of segment JP. What do you think our reason for that would be? Jermaine? Yes, remember, words in a proof, definition of that word. So this would be the definition of a midpoint. Perfect. So this is using triangle congruence, CP, CTC, and then taking it an additional step to prove something else. Excellent. All right, our last one. This one says that segment AB is the perpendicular bisector of segment CD. They ask us to prove that AB bisects angle CAD. So again, if you're asked to prove something like this, you're going to use CP-CTC and then also something, I'm going to put dot, 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 because you'll do something after CP-CTC as well. Do we want to mark our shared side first, because you guys like that? Okay. We know that's reflexive. We know on a quiz we can at least guarantee those points. Now, who remembers what a perpendicular bisector does? What does a perpendicular bisector do? Marquise?
The other 2 triangles, 2 right angles.
Good. It'll form right angles. And what else? Because that's just the perpendicular part. Okay?
2 congruent segments.
Good. So a perpendicular bisector is actually a perpendicular segment bisector. They just don't write the segment part. They just say it's a perpendicular bisector. So it's perpendicular and it's a segment bisector. Okay? So remember, if it forms right angles, we put the right angle box in. What do I write in my proof when I write right angle boxes? Let's call this 1 and 2 just for times. What do I have to write in my proof? Can't say they're congruent. I have to say, Jeremiah, that they are right angles. So I would say angle 1 and angle 2 are right angles. This was the one that was on our quiz. We had to remember the 2 steps from last week. Okay, that would be the definition of a perpendicular bisector. It's technically the definition of perpendicular, but since they told us it's a perpendicular bisector, we'll use that definition. It does 2 things. Now, since they're right angles, we know that technically then they're 90 degrees, therefore they're going to both be equal and congruent. So we'll say angle 1 is congruent to angle 2. Who remembers the shortcut theorem that allows us to say that? Joseph? Good. Our right angles, congruency theorem. Okay, you might want to put stars next to those to kind of review, refresh, and rememorize those two steps have to go together. All right, we also said, so we took care of this element. We also said that they form two congruent segments. So AB is not only creating two right angles, it's also creating two congruent segments at the bottom. So we'll state that CB, segment CB is congruent to segment BD. That's still using the given word, so it's going to be definition of a perpendicular bisector again. The perpendicular bisector does two things, therefore you should be using the reason twice. Do we have enough to prove the triangles are congruent? Which shortcut? No? Side angle side, good. So we'll say, for example, triangle CAB is congruent to triangle DAB. And again, your letters may be different than mine. Maybe you have BAC and BAD. It doesn't matter. When I check your quiz, it does take me longer because I have to check and make sure you did them in the correct order. But that's just side angle side. All right, now, go back and look at our proof statement again. I want to prove that AB bisects angle CAD. To know that this is occurring, what would I need to know in terms of congruency between the two triangles? Maddie? Like this? Okay, it wants me to prove that it bisects an angle. So I wouldn't want to know sides. I'd want to know angles, and which angles would those be? Cal?
Angle CAB is congruent to angle
Good. And I'm going to put numbers up there too, just for the sake of time today, but we could call them 3 letters like he did. We would need to know that angle 3 and 4 are congruent. So we'll put angle 3 is congruent to angle 4 because corresponding parts of congruent triangles are congruent. CPCTC. And so if these are congruent by CPCTC, then AB must be an angle bisector. So we actually don't need line 10 here. Go straight to our proof statement. Ray AB bisects angle CAD. And what would my reason be for that? Helen? Close. It is definition. What type of bisector is this? Not a perpendicular.
Angle bisector.
Angle bisector. Definition of an angle bisector. The definition of an angle bisector is it divides it into two congruent angles. Okay.